Yes. All right. Thank you. Well, it was very interesting, the keynote talk, because I think we sort of, well, we are at the other end of the channel, of course, but we also start with our innovation of education at the other end, at the end that you ended with, namely you named the mathematics that has completely changed. And we started changing the mathematics education a few years ago. I would just like to take you a little bit what we did. So my name is Anoushka Cabot. I'm the Director of Interfaculty Studies, so responsible for all the math courses that we teach through the whole university. I'm also the Academic Director of the Teaching Academy, which is more like the community of all our lecturers, but now I will talk to you from our mathematics role. And well, let's have a look. Let me see if I can go. So this was to show where Delft is. You see it's on the other side of the channel where London is. You all know that. So this is our campus, and actually it looks a little bit like this nowadays, since there are usually 25,000 students running around, but now of course most of them are at home and only a few of them come to the campus. We have 8 engineering faculties, and you also see here the number of scientific staff and the number of PhD students. And so in our mathematics education, we teach most of these students, say about 20,000 of them. Okay. So, well, I think we all agree that there is a need, widely understood need for engineers to think mathematically and to use mathematics to describe and analyze different aspects of the real world that they study. And so I will show you now maybe, well, that finally we would like to end where UCL is, at least I would like to. And I have some very naive pictures to show you first. That's the situation as it used to be from a student point of view, having courses in mathematics and then of course his own engineering and applying this to the real world. And I think now we sort of more or less succeeded in integrating mathematics and engineering a bit better. But then, of course, what we would like to do is to have everything merged together, as we've seen already, and which can actually really happen. Now, our first, so what we did is we started a big program. It's called PRIME, Program of Innovation in Mathematics Education. And I will show you, I'll stay a little bit longer at this slide. So the program is about TuDelft, TU-wide interfaculty education. And there's about 20,000 students, 45 courses, and more than 45 FTE of lecturers involved. And the innovation, well, why did we start a program similar as what Emanuela was mentioning? Students are not always enthusiastic about math because they came to study civil engineering or mechanical, and of course they know that they need somewhere math, but well, and on the other hand, all programs and curriculum start with math courses because that's what everything is going to build up upon. So we needed something to activate students and to motivate them and to increase their study success. And also we needed to think about transfer of mathematics to engineering. So the innovation that we did was evidence informed on educational theory. I'll tell you a little bit more about the team later on. And should be able to scale up, and it's done very much in teamwork, and very diverse team. So we will go into that a little bit later. And what kind of mathematics are we teaching? Well, of course, we have calculus courses, probability and statistics, but also linear algebra, differential equations. And of course, there's also numerical mathematics, but this is not involved in this program at the moment. So we had to think about a different way of education. And so we developed a prime cycle, which is embedded in blended learning, like, you know, prepare, participate, practice for the students. And there's a lot of material that has been developed, and you can all have a look at it when you go to our Prime website at TuDelft. So there are a lot of pre-lecture videos, a lot of interactive polling questions that we use in class, slide packs that have been previously designed and that are used by the lecturers, animations and applets where students can actually see what happens when you just change a few parameters in your functions, and all sorts of other things that I will not go into, but I think they're very nice to have a look at if you like, and they're all open source materials. And of course, one of the main things is also to develop an interactive and online homework exercise platform, which is also good. So one of the things that we tried to was make the students better understand what they're doing in mathematics. So for instance, we developed academic reasoning lessons in a linear algebra program so that they would really be able to reason why, for instance, a statement is true or false, and to be able, of course, afterwards to apply this. We designed computer assignments in Python for the probability and statistics course, and there are context videos for civil engineering and the differential equations program. And the mathematical modeling part is still a challenge. So that is something that we are thinking at this moment, how to really achieve that students actually are able to do this modeling. Now I have to explain that this mathematics teaching is done by mathematicians. And, but we have found out that yes, indeed, to be able to transfer the math to engineering, we need a close collaboration with the other engineering lecturers and students from there. So that brings me to the next slide where the team is shown. So here's a team that has been involved. So there's the director has contact with all the other faculties. Then there's always an educational advisor involved. There's someone from the team of ICT innovation that helps us with implement all the ICT tools that we need. So by the way, the transition from campus to online education was not hard for our math courses. Just, of course, the contact and the interaction with the students is something that we have to keep on thinking about. And then there was a group of lecturers, as Manuela said, the enthusiastic ones that we started with a few years ago, but now there are much more of them participating in actually making the material or developing the material. There are many students assistants involved, not only from the math department, but also from other programs that actually, for instance, master students that did do the bachelor programs and see where the mathematics came back in their other courses. And also since recently, we also have some researchers to actually see what the effects are and to measure whether the things we are thinking of in the or doing in the education actually works, and if not, what interventions should we do? So I think one of the success factors is actually that we did everything in such big teams, so that we involve different stakeholders. And the other thing is that also one of the things that Emanuela mentioned, namely that there's a support throughout the whole university. So we have a big steering committee where a member of the executive board is present, the director of education and student affairs is present, and several deans, a director of education, one of them is actually in the audience here, the department head of mathematics, and also student representatives. Because then from the beginning we had contact with the whole university, and we could collect their feedback. And the other thing that we have been doing from the beginning is to train the people that actually teach. So there's a team developing the material, but then of course many other people are teaching the courses. And there have been workshops from the start from our teaching and learning services, but also amongst each other. A workshop, for instance, to design the ideal polling question to activate your students. So there's a lot of dialogues among lecturers on how to teach, what to teach and who we are teaching. And this dynamics is going on, and I think really improving also the things we are doing constantly. So dialogues with peers and a lot of support is very important. Okay, and then of course there's a scientific approach that we rely on at least information from the evidence. How am I doing on time? And also, yes, the iterative development. So we really started with a small pilot, one course, one calculus course in one program, one linear algebra course and one probability course, and then reviewing and getting student inputs all the time and really doing something with it and actually implementing the changes to improve made the thing work. So it's a continuous process of increasing the skill and improving well, the material, and also reaching other goals. Okay, so I think we were quite happy with that, and so we had some recognition, some national, and also we were also named as an emerging leader in engineering education because of this project. And we now have been recently been nominated for a national prize in the Netherlands for innovation, especially I think because of the team effort that is involved. So now there's a lot of, well, it's called impact here, but I think what I mean is really like change. So it's very interesting to see what's going on worldwide. So a lot of my mathematics colleagues around the world, we keep on talking about how to improve mathematics education on a say a content on the content aspect. But more interesting, of course, is to see what can we now do in curricula actually to have this learning line go through the whole program and to actually enable students to apply mathematics in their engineering and also shaping the future engineer, who has to be much more flexible and has much more complex problems, of course, to go around. So our future plans are many. Also, so not only in the mathematics area, but also now how can we actually build on projects that really will include math and engineering in the real world. So that was something I would like to, this was what I'd like to share with you. And I'm really interested to hear your experiences and ideas and what could help us go on. And I would really love to talk a little bit more also with people from UCL, what's going on. So thank you.
Brilliant. Thank you very, very much. Do we have any questions? Does anyone want to come in, or
I can stop sharing.
I think the scale of it is incredibly impressive. The range of different topics you have. I wonder if you could say a little bit about how the students have reacted to this change. Obviously, you've had a lot of student engagement in the design of it, which I think is brilliant. But
yes,
what sort of reaction have you seen?
Well, this is a cultural change, as we've heard before. So it's a cultural change not only for the lecturers that are teaching the courses and for the programs that are taking the courses, but also for the students. So in the beginning, they really had to get used to the fact, first of all, that they had to really prepare things and be more actively engaged. But in the feedback that we get, they're really happy with it. They liked also the structure of the course, because we also are very keen on structuring the course and showing the students where the course is situated and what the subject is situated in the whole course, so that he can make the links himself and know what pre-knowledge he needs, or she. And so they're enthusiastic about it, all of it, because they start asking us now, couldn't there be a prime for mechanics engineering, and could you not help us to implement sustainable learning goals in our curricula? So we get nice reactions and a lot of questions from the students.
That's very good. couple of questions here. Question about how has the assessment had to change?
Yeah. So before COVID, so the assessments in the beginning did not really change a lot, not enough to my taste, because, well, now for the linear algebra course, when we did the academic reasoning lessons, the reason that we implemented those is that we had already these kind of questions in the exams, but they were usually very badly scored on, and this has improved a lot. For the calculus courses where the mathematical modeling questions, exercises are in, it's also getting better, but I think we have to think a little bit more, still more, how to improve it. Now with the COVID situation, of course, the exam have now become all online. So we are actually now, we use our exercise platform that the students are already doing the exercises on for their homework now also to test them. But I would like to have more peer review or peer assessment, or making them show what they learned in class by presenting something, you know, a subject, or, but it's very hard because we have more than 2,000 students in the course, so it's quite hard to think of it.
And do you think COVID has made other changes to, other than just, I guess, in that assessment area?
Yes, because, well, of course, the lecturers that were not very happy to work with the change. I mean, most of them have been involved in teaching, but they still had their own well, thoughts about how to not activate students, or maybe lecture more than actually involving the students in class with the polling questions and getting feedback. And now with the online situation, it's the only way to communicate with the students. So they really see the added value of that. And I guess that will always also stay. I wouldn't even be against to maybe stick to the knowledge transfer theoretical parts in the big courses online, because a big class of people online is for the student much nicer to be in, because you don't have all the distractions of 700 people around who are maybe doing other things and making noise. But then of course we need small groups on campus to actually make them work on their own specific areas and practice their skills, but also their engineering applications. That would be something that I would like to keep.
The last question from Babby, always a man to see an opportunity. What would it take to extend this outside TuDelft?
Well, what was
I think he's offering.
Yeah, great. Well, actually, well, so the material that we have can be used. Also, the exercise platform is open source, but of course, I mean, what we learn, I think, is how to make such a big change with people. So how to involve people, how to involve the management and the students. And I mean, as soon as you have this idea of getting people working together and inspiring each other, that would be well, really helpful, I guess. But I don't know if I really understand the first first part of this. So I'm trying. What would it take to extend this innovation beyond? Well, just come and work together.
I mean, I think that's something Emmanuel alluded to, that actually, you know, the content and the development is one thing, but fitting it in your context is actually where a lot of the work really comes in. It's
yeah, you really have to see what's going on already and how people are working and thinking and working to which goals, of course. First, and identify where you want to go, and then decide how you do it.
Excellent. Thank you so very much. So we'll move on.